Good morning, everybody, and welcome to the Carpenter Working Group. Let me share my screen with the doc. Did everyone see that?
Yeah.
Awesome, wonderful. Well, let's get started. I see we have our 12.4 documents here. People have started putting community questions in. That's fantastic. Any RFCs people want to review that they don't have in there yet? Going once, going twice. Cool. All right, we'll start with this issue here. I think I saw you on the call, Justin. Do you want to talk about this?
Yeah, so it looks like someone submitted a PR for this issue a few months ago. It's the issue is that it seems that topology spread constraints don't take into account restrictions that are imposed by the PVCs for a stateful set. So if you lose, the person who opened this was complaining about this happening with scaling, but we've also seen it happening if a node is lost and a carpenter needs to provision a new node. It can't, it just endlessly says that the topology spread constraint is unsatisfiable because I think it tries to satisfy the constraint that's on the pod, but it can't also satisfy the constraint on the PVC. So it just gives up and never schedules the node. And then if you delete the PVC, it immediately comes up because it just creates a new PVC in the correct zone somehow. So I think the person almost solved the problem on this PR, but there's some discussion about optimizations maybe that should be done. So first, I guess, do people agree that this is worth fixing? And if so, we're happy to help get this PR over the line because it causes a lot of issues when we lose notes.
Do we know that this fixes the issue? Because I guess I'm not 100% sure from your description that we know this is the issue, or is it like this actually fixes the problem? Do you know, Justin? Sorry.
No, we haven't actually tested this PR. That's true.
Okay.
Yeah, I think there are cases where the interaction between if you have zonal constraints for PVs and then required zonal topology spread constraints, you can get into places where topology spread constraints are genuinely unsatisfiable without recreating the PV, which wouldn't be something that this PR addresses. Because this wasn't, there was, I forget the full details. I created the original issue and I left quite a few details about how it could be reproduced
Mhm.
in that issue. It's not that we don't account for or zonal requirements from PVs. It's that the way they're accounted for is slightly wrong. Um, and the case where it could cause scaling issues was more of an edge case. So it would be good if maybe you could add your example to that issue so we can evaluate if it is the same underlying issue or if it is something slightly different.
Okay, yeah,
Either way, I
we
do
can
think,
put a PSC up, yeah.
okay, yeah. Either way, I think this issue is worth addressing. The issue with the original PR, when I reviewed it back in, I think, June, was the performance trade-offs. And I think, yeah, this is still something definitely worth fixing. And there were ways to improve the performance to make it not an issue, but this topology spread section is a bit of a hot path for Karpenter. And if we basically bring in suboptimal code like performance wise, it could result in pretty large performance regressions for people, particularly with large 1,000 node plus clusters.
Got it. Okay.
So I think
Something,
there is a path forward that is performant, though, just not in the original PR.
Okay, makes sense. Yeah, we can add our POC and take a look at opening a separate PR that maybe addresses it without the performance issue.
Mhm.
Saw you put some ideas in there, so yeah, cool.
Awesome. I
we can
saw
get on that.
Garvin put his hand up.
I guess I don't know if this is related because I ran to this issue when we were running in Azure. I don't know if this is the same issue, so I don't want to sidetrack. But essentially, what happens is that when we manually spin up Azure nodes, it comes up with a topology zone of like 1, for example. But when it's Karpenter, it comes up with like a central US 1. And when manual node exists in the cluster, it's never able to satisfy that constraint because Azure expects, sorry, Carpenter expects a different zone to come up. I don't know if something similar is happening here, where there's a mismatch in zones. If that's not the case, then ignore what I'm saying. And there's a different issue. I'm not sure if that is that the same thing where zones exist where it's never going to be it's not satisfiable because Carpenter expects some other thing for the zone names, and it's not able to spin up those nodes in those zones, or is this something different? Because I didn't look through the whole issue and your issue specifically.
Yeah, I can speak for the original issue it's something different. I'm not sure
Okay.
about the issue you're facing though. That's where it'd be good to get that detailed description in the issue. That way we could map and see if it is the same thing or something slightly different.
Mm-hmm.
Sounds good. All right. Any other comments folks want to have on this before we move on? Going once. Going twice. Cool. Thanks for the submission,
Okay,
Justin.
yeah, thank you.
I have two things, but feel free to jump in between my two. But first thing I want to talk about is the no overlay memory issue. Recently we turned on no overlay to adjust pricing because we have some discounts in ODCR. I mean, not ODCR, but CSP and ISPs. When we turn overlay price adjustment on a large number of node pools, the memory spiked up to more than double. And from my analysis, what's happening is that in the no overlay implementation, we're getting pretty nitty gritty, but then in the no overlay implementation, when we get instance type through the no overlay and it's applying the no overlay decorator over all the instance type, we're performing a deep copy of the instance type to not affect the underlying instance type. But that deep copy means that every get all instance type calls are now making a copy of instance types. And because of that, the memory becomes two things, like one, no pool times instance types that no pool has, and that's covered by an overlay. All that will be replicated in memory for every call. And second is that your memory utilization is very erratic because it's every call, the memory spikes and comes back down, spikes and comes back down. And I don't have, I put a PNG screenshot. I can dump to SVG, which is easier to read. But at high level, you can see that once you have overlay enabled, the memory usage for instance type jumps from like maybe 100 megabytes to like almost 300 megabytes. But this is a short snapshots. And the main thing is because we're doing deep copy and the weight of all the requirements for all the offerings, all instance type are recreated and they're big. I have a fix for this. I didn't want to re-architect because I think Derek is changing how get instance type might work. So I don't know what the answer once we change that looks like. But my fix is relatively simple. So you scroll up to the top, it should link to a PR. The PR is relatively simple. Right next to the open button, there's a PR. Oh, I don't know who's navigating. Like right next to the green, yeah. The fix is simple. Instead of doing deep copy, I changed it to almost like a copy on write, where it copies all the references from the original instance type and simply update pricing and capacity when it's changed. All that is like mostly test. Yeah, right here. So instead of a deep copy, it is doing a partial copy and only update pricing and capacity once changed. And at least from my testing, and I added like a benchmark. I wasn't sure how we want to benchmark from now on or whatever, but for my testing, memory brings it back down to pre a heavy overlay plus maybe a few hundred megabytes simply because now there's the extra decorator on the no overlay. But it prior to this, like yeah, the memory was like maybe 4 or 5 gigabytes of memory. Now it's back down to like a few hundred megabytes. And all this other stuff is just testing stuff. So I want to see if we can get this looked at or merged. Simply, well, we can remove the test if that's too complicated, but I think the actual implementation is relatively simple and hopefully easy to understand this because we're not doing a deep copy, we're doing a partial copy and some logic of like, okay, it matched instance type, there is a capacity change, okay, change that, but then everything else is copying. Because yeah, this is slightly having issues for us is because yeah, now we can't put a heavy price adjustment on a bunch of our node pools because once we do that, the memory blows up.
Yeah, I was taking a look at this earlier. I think your diagnosis of the problem is right. I love that you included your the actual memory
The deep
usage
copy.
things you're
Yeah,
seeing. That makes it really easy to be like, yep, you're right. I will try to take a look at it today and get an
sure.
answer back to you.
Thanks.
Um,
And let me know, like, I added some benchmarking and stuff like that, and I'm happy to do it differently. I don't know what direction we want to go to. Like, it's a shot moving on, like, oh, it's easier to be like, oh, this is the memory usage around this test before, and now it's this. So we can verify quickly, like, oh, there's memory implications when we make changes. In this case, it's only the no overlay parts, but yeah,
yeah. No, I do like that the you do have benchmarking tests to see how this goes, and it will make it easy to like prevent regressions from this in the future. Because if we do, this is a somewhat sensitive place if you blow up memory usage due to overlays, either because
yeah,
of someone's odd configuration or just because they configured it something at all. That's
yeah,
not
yeah.
ideal. Um, Wonderful. Anybody else have any comments on this?
Yeah, I think the one thing we're just going to have to be careful about is making assumptions of how cloud providers are doing caching.
Yeah, yeah.
I think that was maybe the one reason we went with a direct steep copy, and the goal was to improve performance by shifting instance type caching upstream as like part of some future work, probably before node overlay goes to beta or GA.
Mhm.
But if there is something we can do for a cheap and easy performance gain before that, I don't see a reason why we wouldn't.
Yeah,
But that's just the one thing to be cautious of.
yeah, I looked at the Azure provider and it feels like this implementation at least is simple enough that it's okay because all the heavy things are still being copied over uh from a pointer, like the pointer to the heavy things is mostly copied over in the recreation of the instance type. And we're only modifying like capacity and pricing, which feels okay. But yeah, it was hard to understand the contract between the providers because the instance type caches on the provider side. It makes it very hard. So I get why the initial deep copy exists. I was like, okay, yeah, it's very hard to understand there.
Yeah, I think based on the way you described it, what you're doing sounds fine. We do similar things elsewhere in the AWS provider, at least
Yeah.
in the launch path. So
Like
yeah,
even in the offering, it's kind of similar in this, like it do a partial copy of the requirements, so it doesn't regen everything. So yeah,
yeah. I was just bringing it up as something to make sure to pay attention to during review, but
yeah.
yeah, hopefully this is something we can go forward with.
Cool. Any other comments? Going once, going twice. All right. Issue number two, Nitro Enclaves. This is AWS provider specific.
Yes. Yeah, I updated the task with the Nitron Enclave. I need to test it out. So that's on my side. I'm just wondering, I added integration tests. I'm wondering if I I don't actually know how to run the tests. Um, I don't know if my fork of it can run it because it seems like it requires some AWS integration. I just wasn't sure and if I'm missing something because I don't have AWS account that I can just launch things directly into. So I'm wondering like, what's a good way for me to test? Or if I do need an AWS account, I need a EKS account, then yeah.
I don't know if you need an EKS account or if any cluster will do. I think, well, it's provider, so I assume you have to have an EKS cluster.
Well,
Um,
Okay.
I think some tests make an assumption that we can hit
Oh, I think Jason
I
cut
think we
off.
lost. I think we lost you.
implement.
Uh, You back?
You completely cut off, Jason. I can hear, I think.
I don't know. Can you hear me now?
A little stuttery, but yes.
Okay, keep it brief. It should be possible. We may have some assumptions that we can call described cluster,
Okay.
but
I
fundamentally it should work with any Kubernetes, well, any AWS Kubernetes cluster.
okay. I can try. It will be the ET test, I'm guessing, because you're highlighting over that there.
Yeah. If you
Yeah, this
have a
should this should
PR,
run the EDs.
if you have a PR ready though,
Yeah.
um,
The
you
the
can reach
actions are
out
not
to like
triggering.
any of us on the Carpenter team. We can manually trigger them. From for like security reasons, it's
Ah, okay.
the ET tests need to be triggered by someone
That makes sense.
with
I
like team
mean,
membership.
okay, that makes sense. Yeah, I have a PR. If you can trigger one to see, I can fix whatever issue comes up. I just wasn't sure if I can make a compliant cluster and AWS that runs the test properly. So if you guys have something that'll make it quicker to turn around.
Yeah, is it Carpenter Snapshot or Carpenter Test? I can't never remember.
Snapshot.
Snapshot. Okay. So let me know and I'll comment this on your thing and it'll run the tests for you whenever you're ready.
Okay, thank you. That's all I have for that one. Thanks.
Cool. I don't see any other issues in the working group. So, and does
I
anybody
have a
have any
question.
free-form comments?
Yeah, I
Yeah.
have one. So now that the granular resource limits has been accepted for the autoscaler at least, and also Carpenter, I'm wondering like what's the path forward for that? Like, does the maintainers for Carpenter have a plan for this, like implementation wise? That's all I'm wondering.
Yes, I think there's an issue outstanding for it for us to help gather input from people. The next step is going to be an RFC for, um, I think I opened up a limit issue. I might not have. Oh no, just the buffer API. Okay, the next step is I'll open up an issue for it just so folks can start putting their thoughts in it if anybody has specific use cases they care about for it. And then the implementation from the like what are we going to implement and when, I was looking at the original proposal with Ellis in SIG Autoscaling, and we believe that they are going to be soft limits here as well, which I know is not maybe what you want to hear.
No,
Um,
no, no, no. That's completely fine. So I didn't
okay.
join the auto scaling SIG this morning, so I didn't know. But yeah, I just wanted to know if there was an issue, and since there's not, then yeah, please tag me on that if you get that created. But yeah, that's all I want to know. Thank you so much.
Absolutely. For folks who are curious, um, let me link the cap. And I'm specifically talking about there's a section here where uh, soft and hard limits. Behavior of the limits should be in line with the current implementation of the limits in node autoscalers is what's being discussed, and it has been merged. So it looks like that's the proposal we're getting. Any questions, comments? All right. Going once. Just taking some notes here. Going twice. Wonderful. Anything else folks have? All right. I guess we get 30 minutes back. Thanks everybody for
Well,
coming. If you have any outstanding PRs or need anything to take a look at, please use the Kubernetes Slack to keep in touch with members of the community and the team. And thank you so much for coming.
thank you.